As you can see, I've repeated the co-edition for all the color channels and for the luminance channel. And well, so from a scientist's point of view, we are done here. You can have a look at your data directory in your folder, or there are several subfolders called Coed Blue, Coed Green, Coed Luminance, Coed Red, and within those subfolders you will find a final co-edit image. You can also open your image browser again and open, for instance, your final luminance picture, and well, yeah, you can now do your little science or whatever with it. As you can see in this above area here, the co-edit pictures will have some VCS coordinates in their fits headers, so you can do a little astrometry or whatever. Okay, but as a pretty picture astrophotographer, you might want to create a color picture, and yeah, as scientists normally work with black and white pictures, this is an additional step in Theli. And let's have a look in the miscellaneous section. There you will find the task prepare color picture. Click it. Well, and again, here are 4 subfolders or subtabs to follow step by step. Have a look at the first section. Under select co-editions, you simply can choose your co-edit files, which are automatically chosen by Theli. If you click go get co-edit images, you will get some cropped fits files out of this. Again, you have to define a statistics region, and you do it in the same way like we did before in the sky subtraction process. So open again this image, set your screen transfer mode to set scan. Well, yeah, this seems to be like a very dark area, so choose an area with sky background and also some not saturated stars, and write down the coordinates. It's x 2751 and y 846. Again, imagine this little box, and yeah, another x coordinate is 2867, and for y 718. Go back to Theli and fill in those values here. X minimum is 2751. X maximum is 287. 67. I'm sorry. 716 and 846. Okay, now we could move over to the next tab, which is called Elim. Well, you can create an enhanced artificial luminance, and yes, it makes sense in 2 cases. For instance, you've only collected RGB data. It makes sense to create an artificial luminance data out of this RGB data, which is called an RGB. So yeah, well, the results may look a little bit better concerning the noise if you do so. The second case is you can create an artificial luminance out of your LRGB data, so-called LRGB RGB, and to do so you can choose between two different combining methods: the good old mean combined mode, or a noise normalized or noise weighted mode again here. And this is called Elum chi-square. I always create it, and in my final image processing I decide if I use it or not. And it may have a positive or no effect, or even a negative effect on your final image. To create such an artificial luminance out of your LRGB data only makes sense when each color filtered exposure has a comparable exposure time to the exposure time of the clear filter. For instance, if you've collected 2 hours of luminance data, each color channel should should have an exposure time of 2 hours as well. So I sometimes do it if I collect data for dark nebula or things like that. Well, as I said, I always create the Elum chi-square and decide later in my final image processing if I use it or not. Go over to the color calibration, a task most of you might be interested in. Well, first of all, choose the right color channels corresponding. Well, and you can choose two different methods to compute color calibration. The one method is with a photometric catalog, or the simple average white method. Average white makes sense, for instance, if you are doing wide field photographs with a lot of saturated stars, or if you do narrowband imaging. But most of you might be interested in the photometric way. Therefore, you have to choose a catalog again. You can choose between SDSS, which is very, very good for color calibration, but just covers a northern part of the sky. The alternative is Nomad, which covers the whole sky, but it's a little bit blue shifted, so you have to correct this manually later. So M8 is not covered by SDSS, so I choose Nomad. Again, choose a server. If the default server is offline, choose another one, and simply click Calibrate. And after a short while, your factors for each filter will show up here in this boxes or fields. Well, after this, you're done more or less. You will have, you will get a sub folder which is called Color Theli, and within this subfolder Color Theli you will find some FITS files which are named blue cropped, green cropped, Elum chi-square, your artificial luminance, green cropped, red cropped, and luminance cropped, and you can transfer those FITS files to your image processing program, for example FITS Liberator or PixInsight or whatever you use. Okay, the color calibration is done. As I said, yeah, you're done here if you have reached this point. But if you would like to transfer your data directly into Photoshop, which is not able to read FITS files, you have at least to transfer your FITS files into TIFF files by at this last tab. You've defined a statistics region earlier, so just click Get Statistics, and there we go. You could now adjust your TIFF minimum and TIFF maximum values here manually. TIFF minimum for your sky background and TIFF maximum for the stars. Well, give those statistics a try, and if you're not satisfied with the results, you can repeat this step, and well, you maybe decrease the TIFF minimum or decrease or increase the TIFF maximum values. I use these now and simply click convert fits to TIFF, and after a short while you can have a look at your color Theli folder again. I refresh it. Voila, you will find your color calibrated TIFF files, which you now can transfer to Windows first of all, and you can open them in Adobe Photoshop. Well, that's it in Theli. Thank you very much. I will show you some miscellaneous tabs also. I sometimes make use of the animation function in Theli, which offers you a very nice way and simple way to do some animated GIF files out of your data, which is nice to show movements of small planets or comets or whatever. You could get some plots about image statistics, such as seeing or background noise or whatever. It's very interesting to have a look at those image statistics plots after your photographic session. There's an immobilizer which shows the curvature of your setup. Yes, and well, this is it in Theli. I hope you have enjoyed these tutorials, and well, thank you for visiting.